Complete combustion of propane can be represented by the equation shown below, CH3, CH2, CH3, that's the propane molecule, plus 5 oxygen, produces 3 carbon dioxide and 4 water molecules. And the delta H for the reaction is given, and it's approximately what we calculated in the previous problem. To this, it's rounded slightly differently, but approximately the same. So something to note here is that the delta H is negative, so that means this reaction is exothermic. And so when we think about our delta H equation for calculating delta H for the reaction using bond enthalpies, remember that it's the sum of delta H for the bonds that are broken minus the sum of the delta H for the bonds that are formed. And so if we get a negative number, that means that this energy, the energy to form the bonds, is greater. The energy to form the bonds is greater than the energy required to break the bonds. We can eliminate answer choice D based on that because it says breaking bonds requires more energy than making bonds. So this is not true. In fact, the opposite is true based on what I just said. Part C, we can also eliminate. It says more bonds are formed than bonds are broken. So from the previous slide, we figured this out, but we have 8 carbon-hydrogen bonds and 2 carbon-carbon single bonds in the propane molecule, so a total of 10 bonds broken there, and 5 bonds broken on the oxygen double bond, so a total of 15 bonds broken. And then the bonds formed, so carbon dioxide, remember, is 2 carbon-oxygen double bonds times the coefficient of 3 is 6 bonds formed there. And we found previously 8 bonds formed to form those 4 water molecules. So 6 plus 8 is 14 bonds formed. So 1 less bond is formed than is broken. And then answer choice A says stronger bonds store more energy than weaker bonds. And this is actually incorrect. It's the inverse that's true. And it seems a little counterintuitive. But the potential energy between stronger bonds is less than the energy stored between weaker bonds. So stronger bonds store less energy than weaker bonds. So that is not true. Leaving us with B, so let's just make sure that makes sense. Forming a stronger bond releases more energy than forming a weaker bond. And that is true. We can just use that same counterintuitive principle from part A. So if a stronger bond stores less energy, that means that more energy must have been released when it was formed. So we get answer choice B. Forming a stronger bond releases more energy than forming a weaker bond.